Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why some kids seem to get math so much easier than others? And how do they actually learn to figure out numbers? This new study dives into how kids learn to process number order and how that connects to math skills. What if I told you that how kids sort numbers might actually be a key to how well they do in math, and that the way they learn to do it changes as they get older? That is the big question this research tackles. They wanted to see if kids and adults use the same strategies when looking at number sequences and if using certain strategies makes them better at math. So imagine you see numbers like 1, 2, 3, that is in order, right? But what about 1, 3, 5? That is also in order, but it skips numbers. Scientists have noticed that how well people can judge if a sequence of numbers is ordered is really linked to how good they are at math. Especially as they get older, this link gets stronger over time. One big idea is that as we get older, we start using our memory more to solve math problems and to figure out number order. Instead of counting or figuring things out step by step, we just know the answer because we've seen it so many times before. Think about knowing that 2 plus 2 equals 4 without having to count. The researchers thought this might be happening with number order too. They believed that kids would start using their memory more and more to check number sequences as they got older. And this use of memory would be why their math skills improve. So, to test this, they got together 3 groups of people. Younger kids, basically around 8 years old, older kids around 10 or 11, and adults. They all played a game where they had to look at 3 number sequences like 1, 2, 3 or 1, 3, 5 and say if they were in order or not. For the kids, they also did a math speed test, trying to answer as many addition and subtraction problems as they could in a minute. This was to measure their math fluency, how quickly and accurately they can do math. Now, here is the really cool part. After each number sequence they looked at, they had to report how they figured out if it was in order. They had 4 choices: memory retrieval, decomposition, arithmetic, or other. Memory retrieval means they just knew the answer, like they remembered the sequence. Decomposition meant they broke it down and checked each step, like comparing 2 to 1 and then 3 to 2 arithmetic, meant they used math to figure it out. And other was for anything else. They collected a whole bunch of data and then started crunching the numbers. They filtered out super fast or super slow answers and also answers where people got it wrong to make sure they were looking at reliable data. First, they looked at how fast people answered. As expected, adults were the fastest, followed by the older kids, and then the younger kids. This makes sense because older people are generally faster at tasks. Also, they found that people were faster at judging consecutive sequences, like 1, 2, 3, compared to non-consecutive ones, like 1, 3, 5. But the really surprising stuff came when they looked at the strategies people reported. Remember how they thought kids would use memory more and more as they got older? Well, the opposite happened. Younger children reported using memory strategies the most, almost 89% of the time. Older kids used it a bit less, around 83%. And adults, they reported using memory strategies way less, only about 45% of the time. This was totally unexpected. Even more interesting, a lot of the kids, especially the younger ones, reported using the exact same strategy for every single sequence. They were inflexible, sticking to one method no matter what. Adults, on the other hand, were much more likely to switch strategies. To check if these strategy reports were actually telling the truth about how people were thinking, they looked at the response times. They found that when kids reported using memory strategies, they were actually faster than when they reported using decomposition strategies. This suggests that their reports probably weren't just random guesses. Then they looked at how this connected to math skills. They found that for older kids, the more they reported using memory strategies, the better they did on the math fluency test. This part fit with their initial idea. But for the younger kids, it was more complex. Their math skills were linked to how fast they did the order task overall, and also to how fast they did it when using memory or decomposition strategies. So, what does this all mean? The main finding that surprised everyone was that kids, especially younger ones, reported using memory strategies more, not less, than adults. This goes against the idea that there is a straightforward increase in memory use with age for order processing. One theory for this is that children might not be very good at knowing how they solve the problem. They might not have the self-awareness called metacognition to accurately describe their own thoughts. They might just pick the strategy that seems most likely or easiest to describe, and memory sounds like a simple, direct way to get an answer. Think about it. If you just knew an answer but couldn't explain exactly how, you might say, "I just remembered it," because the other options, like decomposition, sound like explaining a complex process. The researchers also noted that when they gave the strategy options, memory was often listed first, and kids might have just picked the first one. This lack of metacognitive insight could explain why many children reported using only one strategy. They might have been stuck on that one strategy because they didn't have the awareness to choose a better one or understand when to switch. However, the researchers also acknowledged another possibility. Maybe kids are genuinely over-relying on memory strategies. They've seen this in other math tasks where kids get stuck using one strategy that isn't always the best. They might just keep using the memory strategy because it is what they've always done, even if it is not the most efficient for every situation. And the fact that memory strategies were linked to faster speeds for kids, and that kids use them more for easier sequences, like consecutive ones, thus suggests to rest something real going on with their reports, not just random picking. This strategy inflexibility in kids, using the same strategy over and over, could even explain why some kids initially struggle with number-ordered tasks, like saying non-consecutive sequences aren't ordered. It is not necessarily that they don't understand the concept, but that they're rigidly sticking to a strategy that doesn't work for those sequences. So, to wrap it up, while the study didn't show that memory use increases with age for order processing as they expected, it does suggest that using memory strategies, or at least reporting using them, is still really important for math skills, especially for older kids. The big takeaway is that kids might be using memory strategies more than we thought, possibly due to not fully understanding their own thinking processes, or because they are genuinely inflexible with their strategies. This inflexibility could be a key factor in how children develop their math abilities. It seems like understanding how kids choose and use strategies is super important for understanding how they learn math. The researchers also pointed out that more research is needed. They can't definitively say if the kids were just bad at reporting their strategies or genuinely stuck using them. Future studies might need to use different methods, like watching where a child looks on the screen with eye tracking to get a clearer picture. It is fascinating to think that how we learn to sort numbers and how we feel confident about our math answers might be tied to these deeper cognitive processes. It really highlights that learning isn't just about knowing facts, but also about how we think about those facts. What do you all think? Have you seen this kind of strategy and flexibility in yourself or in kids? Let us know in the comments below. If you enjoyed this deep dive into the amazing world of the child mind, please give this video a big thumbs up, subscribe to Rubin's Mind Lab for more brainy content, and hit that notification bell so you don't miss our next exploration. Thanks for watching, and we'll see you next time.